Okay, so waves, and when we say waves within the domain of mechanical waves, first of all we have sound waves in mind. Okay, so there is a proposition, but I will put that into discussion later after reaching a certain point. To begin with, velocity is the modulus of elasticity by the density under the root. This is the basic proposition to begin with, and in some other video we can have a segment on it as well. So from the basic laws of gases we know that PV is equal to constant. Yes, so P1 V1 is equal to P2 V2. We can put it this way. So we have this certain proposition that P1 is equal to P and P2 is equal to P1 plus delta P. The differential change plus the initial pressure gives us the final pressure. Okay, and similarly V1 is equal to V and V2 is equal to V1 plus delta V. Okay, this is for reaching certain forms. So when we say PV is equal to constant, let's say PV is equal to constant, which it means that PV is equal to P plus delta P as the pressure is increasing, and V minus delta V as the volume is being decreased due to compression after a slight increase in pressure. Okay, so this is logical, and once we have this we can expand it. PV is equal to PV plus delta PV minus P delta V minus delta P delta V. Yes, I'm not wrong. This is the expansion. So PV cancels out on two sides of the equation, on the right and on the left. So what we have now is delta PV is equal to if you take P delta V to the other side and delta P delta V to the other side, and then uh, okay, let's do it simply. We bring these terms to the left side. P delta V plus delta P delta V, and this becomes equal to delta PV. Yes, so we have this form now. Or resuming with this delta PV is equal to P delta V plus delta P delta V. Okay, so delta PV is equal to delta V into P plus delta P, just the final pressure P2. Yes, change in volume, and here the volume times the change in pressure. So what we have is delta PV by delta V is equal to P plus delta P, you see, and we have to be careful because we are trying to reach certain forms. P plus delta P, now we switch the sides, delta P by delta V by V. We took P from here down below. Yes, which looks something like this, delta P by 1 divided by delta V by V. Okay, so basically the altered pressure is equal to delta P by delta V by V. Yes, okay, so we carefully make a substitution here. Okay, so what happens is that we have this form P prime is equal to delta P by delta V by V. Yes, this is what we have. Now delta P is somewhat equal to stress, and delta V by V is change volume divided by volume. This is approximately equal to strain in mechanics. Okay, this differential change in pressure can be attributed to the changes in stress, and uh, ratio of change in volume to the initial volume can be attributed to the strain. So we have this general form which says stress by strain, and in mechanics this is equal to modulus of elasticity. Okay, so the final pressure or the ultimate value is equal to modulus of elasticity. Yes, modulus of elasticity. And we have the parameters for air, because air is the fluid in this case, as sound waves or mechanical waves which vibrate through the air. So now we do the back substitution. So to begin with, we have this form which I didn't write earlier. So the form says V is equal to E by rho. Yeah, I wrote it here. E by rho, modulus of elasticity by density. This is where we started under the root. This is velocity. Okay. So now we know that modulus of elasticity is equal to the final pressure, P prime. So in this case, now we can approximate the velocity V to be P prime by rho density under the root. Yes, let me just do it again. P prime by rho under the root. And pressure in case of fluids is equal to basically rho of the fluid, acceleration due to gravity, and head, the height. Okay, so rho g is the product of a constant which can be called gamma h. So we can be written as this is what changes h, the deviations, the crest and trough deviations, let's say the height changes in the fluid. So V is equal to gamma h prime V is equal to rho gh by okay, let's make it simple. V is equal to rho gh prime by rho, but this rho is slightly different because there are pressure and volume changes, so let's call it rho prime. So this is the form that we have. P prime is equal to rho prime gh prime. There's this compression and this due to pressure and decrease in volume, so density changes, and so V is equal to rho prime gh prime by rho, the initial reference density. So this is an interesting form for waves, particularly the sound waves, and yes. So we look into the Laplace correction. It's a little tricky, but not difficult. So we have a go at it. Yes. So the Laplace's correction Yes, the form says initial proposition PV to the power gamma is equal to constant. So this is the thing here. Instead of PV is equal to constant, so PV to the power gamma is equal to P plus delta P into V minus delta V. This is what happens when you put more pressure. There's compression. R we know it's equal to okay. Gamma, or let me just clarify. So PV gamma is equal to P plus delta P to V minus delta V, and gamma is also equal to Cp by Cv, the constant heated specific heated constant pressure by specific heated constant volume. Excuse me. Okay, so we take the form PV to the power gamma is equal to P plus delta P into V into 1 minus delta V by V. We make a bit of a change and to the power R. So CPV to the power gamma P plus delta P into V gamma 1 minus delta V by V gamma. So V to the power gamma cancel out, P is equal to P plus delta P and 1 minus delta V by V to the power gamma. So now we do this binomial expansion for substitution, which in mathematics says 1 plus x to the power n is equal to 1 plus n into x plus n into n minus 1 by 2 factorial into x square and so on. Okay, so in this case we have n is equal to gamma and x is equal to minus delta V by V. Yes, and we do the expansion in this equation. So, this part of the equation, 1 minus delta V by V to the power gamma is equal to 1 minus gamma delta V by V and so on. And when the powers of delta V increase from 1, we start neglecting the terms because they're too small. Negligible part of the equation here. Okay, so very easily we can write 1 minus delta V by V to the power gamma is equal to 1 minus R delta V by V. This is the approximation now. Okay, here. And now what we start doing is we do some mathematics. And to begin with, we have this thing going on. P is equal to P plus delta P into 1 minus delta V by V to the power gamma. So what happens is something which needs more space. Okay, and P is equal to P plus delta P into 1 minus delta V by V to the power gamma. And we open the terms P plus delta P, we do the substitution, which is 1 minus, for this second term we put the form from the binomial expansion, which is gamma delta V by V. Yes, now we start doing the mathematics. P is equal to P plus delta P minus P gamma delta V by V minus gamma P gamma delta P gamma delta V by V. Okay, delta P gamma delta V by V. So the term with two delta quantities can be assumed as negligible because the product of two small things is even smaller. So gamma delta P delta V by V is roughly is equal to 0, and P cancels out on both sides of the equation. So what we are left with is delta P is equal to, we take this to the other side of the equation, we're left with okay, so we're left with 0 is equal to, as P minus P is equal to 0, delta P minus gamma P delta V by V. Okay, so delta P is equal to gamma P delta V by V. Yes, gamma P delta V by V is equal to delta P. So the form after one more iteration becomes gamma P is equal to delta P V by delta V, which says gamma P is equal to delta P by delta V by V, or delta P by 1 to make it more clear is equal to delta V by V. So which means gamma P is equal to delta P can be approximated to stress, and delta V by V can be approximated to strain. So gamma P is equal to stress by strain. Gamma P is equal to, and stress by strain is basically modulus of elasticity. So we have this E here, and as we know that V is equal to E by rho, V is equal to E by rho under the root, and E now is gamma P, so V is equal to gamma P by rho under the root. Okay, yes, so this is an equation for us. V is equal to gamma p by rho under the root. So we'll do a little bit of more work. Which is worth the time, as V is equal to E by rho under the root. So V is equal to gamma p by rho under the root. Gamma p